recording. This is going to be an explanation of something that I did before with an unprepared, that is an empty worksheet. Now I will use a prepared worksheet. And I think a prepared worksheet works better. So I'm going to share my screen. And here's a prepared worksheet. Here it is. Yes. And let me repeat again that I'm using my own Maple private license here to show how you can use Maple for educational purposes. And I will put this on YouTube for everybody to see, including students at the VU. Okay, a worksheet, a Maple worksheet comes with black and blue. Black is text to explain what we do. Blue is output of the commands, and red is input of the commands. And the blue part is the one that you should look at, but it's instructive to look at the text, and sometimes it's instructive to look at the input, because it tells you how you can think about this when you want to program something. But you will not have Maple, so you will have to use the ideas in the command lines to write your own programs. And like I said, I prefer Maple above Mathematica. Restart. Oh, and you already see some output here, but I'm going to, under evaluate, I'm going to say remove output from worksheet. Okay, and here we are. Restart. Meet the unknowns. There are two of them. Define the equations. Okay, you don't see anything. Now you do. Yeah, I show the equations, but they have names. Li, L1 and L2. Okay, the equations. And here I wanted to pick an arbitrary set of coefficients, and then I invented a complicated formula to do so. And then immediately I plot the solutions of the individual equations. So ignore all this nonsense. This was just trying to be smart in generating examples. This is an example I generated. And this is two lines. And each of these lines is a solution set of one of these equations. And yeah, maybe you should figure out which one is which. And it's not the best window that I took, because you do not see all the intersections. If I put here 4, this is better. Now you see all the intersections. 1, 2, 3, 4, all the intersections with the axes, and you see the intersection of the two lines. Okay, and I hope by now you're familiar with the fact that you get the intersection points with the axis from putting one of the variables equal to 0 in the equation, and then you get the points of intersection with the axis. But what we want is this point of intersection. This point of intersection, the intersection of the two lines, corresponds to the solution of this system. Okay, I'm counting on the fact that what I just said about solutions of two linear equations and a point of intersection being the solution of the system of two equations, that's not completely new to you. But let me summarize. Both equations define lines, and the point of intersection will be the solution of this thing. And now here I'm introducing some solution tricks. Okay, 6 times L1, that's this equation. That's a different equation from this one, but of course it has the same solution. And 6 times L1 I can add to L2, and then I can add the 2. So I can take this new first equation and add it to the second equation. And we can add equations. And by combining these tricks, we see that we lose a variable. Okay, we can add equations, and now we're done, right? What's the solution? Okay, you solve for x2, and then you put it in first equation, or maybe better this one, and then you solve for x1. So that's, I would say, high school mathematics. More than that. And the option is that we can add equations, we can multiply them, and now we're done. What's the solution? Well, I just told you how to find it. Okay. And now comes the basic idea of this whole course. We're going to represent equations by rows, and the operations with the equations can be expressed in terms of operations with the rows. So here are my two equations, and here I introduce two rows. The first row, and here I use two rows simultaneously. And what I just explained in terms of equations, I can also explain in terms of rows. Okay? We can multiply the rows, and then we can add the rows, and we can write the same commands in terms of the rows. Yeah, so 6 times the first equation plus 2 times the second corresponds to 6 times the first row plus 1 times the second. 6 times the first, 1 times the second. And this is the equation, and this is the row. There's more information in the row, because you also see the 0 here, which has been suppressed here. There's no 0 times x1. Yeah, so for programming purposes or for efficient solution methods, whatever, it's much better to work with, cleaner to work with these rows, because you keep the information that something is 0, and you have to memorize that this one stands for the coefficient of x1, and this one stands for the coefficient of x2. So with rows we have a cleaner picture, and the rows make a matrix. The augmented matrix. The first time I heard the word augmented, I had to look it up in the dictionary, because I didn't remember it from my high school English. It contains this augmented matrix. It's called augmented because it contains this matrix with this third column augmented to it, if you like. Okay? So this was discussing the example and a partial solution method to the example. And now I'm going to prepare you for thinking of this in terms of general equations and trying to understand the general solution method, not in terms of the example, but in terms of the coefficients, which may be completely general. So here I introduce the general system of two equations. Yeah? This L1 and L2, the two equations, we're going to represent the equations by rows. Here they are. Yeah? This was two commands to represent them. The first row and the second row. And of course, that's being a bit stupid. When you do two things which are the same, but just the index changes, then you use a loop. Okay? And the two rows make a matrix, the augmented matrix. Okay? And the augmented matrix contains, you can extract from that, the coefficient matrix. You just take the first the two rows, but only take the first and the second. Yeah, the entries of a matrix have two indices. Okay, and you can extract also the B's, as these do. Yeah, so the augmented matrix consists of the coefficient matrix and the matrix of the things, the vector of the coefficient, not the coefficients of the given right-hand side. Okay, all this is of the equations L1 and L2. Yeah, summing up. This is just to show off that I know how to use for statements. And yeah, so of course, yeah, okay, all you guys are computer scientists or are going to be computer scientists. And I don't know which program you would use to do this. Okay, here I inserted a page break to separate what comes next. That's another example. Another example. I just did something to get me some equations. Here I got me some equations. So all this was a rather smart way of getting me some equations. And the two equations have solution sets. And these lines are, yeah, they're not going to have a point of intersection because they're parallel. So our two equations, L1 and L2, of course I can turn them into rows again. And then I can, okay, so I see that, yeah, why not simplify them? Yeah, so if you, this is a generated example by something arbitrary. The book is full of cooked up examples. I don't like cooking. And then there's cosmetics to make them look simpler. Okay, I don't like cosmetics either. So if you don't cook up something, then don't do cosmetics. But still, you can do this cosmetic procedure, simplify the equations. This way they look nicer. And now I can do the same trick that I did before. I subtract them or add them, whatever, to get me rid of some of the entries. So this will get me rid of x1, but oh yay, it also got rid of x2. So now my new second equation that I want to use to solve something, all of a sudden is this, yeah, this is not an equation, this is a contradiction. Yeah, there should have been something with x2 here, and there's nothing with x2. Yeah, so no solutions, explain why geometrically. Yeah, I already explained this, right? And modify the example to get a system with infinitely many solutions and characterize the solution set in the plane. And see what you get in terms of the row. Then. For this example, you get these rows. And when you combine the rows, you get this row with two zeros here and something non-zero here. Yeah, so that's already answering the question. Think of an example where you get a zero here as well, and then there's nothing to solve, and everything is a solution. No, not everything is a solution. Then only the first one here, this first row, defines an equation here, and then you only have your line. So if both, in general, you will get for two equations with two unknowns, unless there are no entries in the equations, which we will not allow for defining a system. You will get that the solution set is either a point, a line, or nothing, the empty set. Okay. And all this, of course, generalizes to systems with more equations, more unknowns, and then we do not have to take the number of unknowns equal to the number of equations. Okay, so this is a general introduction of two systems with two equations and two unknowns. And this is the first time that I do it with a prepared Maple worksheet. Now I'm going to stop sharing. And now I'm going to stop recording, leave this meeting, and then automatically this will download in a directory on my lazy disk. And then from there I can upload it to YouTube. And then when I upload it to YouTube, I go to YouTube, and every time I see a suggestion for a YouTube movie that I might like to see based on my history. And sometimes I will share some of these. But on the other hand, I have to select fitted for children. So I have to be careful with the links to the videos that I include. And another comment is that in YouTube, I can add comments to the videos. And these comments can be edited, and they can also be used to refer to other links. And they can also be used to make small corrections for slips of the tongue. And these will occur frequently. Okay, so stop recording. Bye for now.